All right, so I wanted to do a few more examples for graphing sine, just for graphing sine and cosine basics. Okay, so here you're going to see a few things. I'm going to do 3 different problems. We're going to talk about how to take these out and talk about the approach. Number 1, identify your elements, right? We're looking for the A and the B in the problems, right? So A comes from the value up front, B comes from the value attached to your theta, right? Here we have 3 and 1/3. Second thing I'm going to do is I'm actually going to kind of figure out what the amplitude and what the periods are, right? So we did this here. You see, amplitude is 3. 2 pi divided by 1/3 gives us 6 pi. We multiply by the reciprocal. Step number 1 in graphing, we're going to take our midline, since we don't have a plus k here, that's going to be 0. The next part is to add and subtract a to whatever your midline is, right? So it goes up to 3 and down to 3. The next part would be to actually calculate the increments so I can figure out what this is going to do, right? And so if I look at it this way, you can calculate your increment like this, right? 6 pi, it's the period, divided by 4, that's going to give me 3 pi over 2. In this example, we are going to add each one of those values here. I'm going to show you how that math works just like this, right? Here we have me adding up the first value plus the increment to get obviously just 3 pi over 2. Then we're going to add from there, and I'm going to add 3 pi over 2 every time. Now, I'm doing the math here one at a time. In practice, it's not what we really do. We're adding 3 to the numerators. 3 plus 3 is 6, right? 6 plus 3 is going to be 9. We know that the 3 pi, this is how I would do it, just kind of illustrating it out. But I'm really just adding 3 to the numerator, and then I'm eventually going to reduce all these values, right? So we have, that's not 3 pi over 3, that's 3 pi over 2. I'll correct that in just a second. But normally when I kind of walk you through these kind of questions, I would say take the top value here, take that number, add it each time, and then simplify it as you come along. All right, so here we go. We're going to correct that. It'll be 9 halves. Then we're just going to add 9 plus my increment again. 9 plus 3 is 12, right? 12 pi over 2. 12 divided by 2 is obviously just 6 pi. And we knew from original value that from the start to the end, I should go from here all the way to here. It should be my period. It should be 6 pi. And as long as I don't have a phase shift or a vertical shift, all this stuff is pretty straightforward. Now, let's graph our point. We're graphing cosine. Top comes down to the bottom halfway through, and it comes back up. Then I'm just going to create my curve like that. And that's how we would graph a cosine function that looks like this. Let's do this with sine now. If we have y equals 1/3 sine of 5x, I'm trying to come up with some kind of unusual values so that you can see how it would work out. If I have a fractional value for a, like we do here, the amplitude is just going to be 1/3. That's actually really easy to manipulate. And so here we're going to have a 5 as b, so 2 pi divided by 5. That doesn't simplify, so you're just going to leave it as 5 halves. That's actually not a big deal. We're going to take our value there. Midline stays the same. We're going to add my amplitude, and we're going to subtract my amplitude. Because we're adding and subtracting from 0, that's why you get a positive and a negative value. That's not always going to be that way, but for now, that's how it is. We're going to add our 4 points in the front of my original initial point. We need to find our increment here. And so we're going to do that by simply dividing my period by 4. If you remember, when you divide with fractions, you multiply by the reciprocal, right? And so what you're going to find out is you're going to get 2 pi over 20. That reduces obviously to pi over 10. So my increment, the thing I'm going to be adding and subtracting, is going to be just that. 1/10, 2/10, 3/10, and 4/10. And I can reduce those for some of them, but I'm adding a tenth every time. Like I said last time, it's just really adding a number in front of those values, right? So 0 plus a tenth, plus a tenth, plus a tenth, plus a tenth. And if they do reduce, like the ones here that are even, 2/10, and 4/10, we'll reduce those down to whatever we can. It's nice to have those reduced. Now, in practice, if I see this, I know 2/10, I can reduce that by dividing by 2. I'm probably not going to do this step. I'm just going to go straight to putting pi over 5. This is sine, so we're going to start at the midline, go up, back down to the midline, minimum value. Remember, I'm trying to stay in line with my 1/3 here, and then back up to my midline as well. And that's graphing the sine function that has this kind of values to it. Okay. In this one, I wanted to kind of create some unusual values that you see for a and b, or at least give it a negative, right? How do we deal with reciprocal, or not reciprocals, but reflections over the x-axis? We're going to write these out. We clearly have a -4 for my a and a 2/3 for my b. If I work these out, notice the amplitude. Notice what I wrote down. A is a -4, but the amplitude is always the absolute value of whatever a is, so we end up with a positive value for amp. My amplitude is always positive. Never give me a negative number here. Period, 2 pi divided by my 2/3. Here again, I multiply by the reciprocal of the fraction, so 3 times 2 is 6. Now, if you saw quick, you could have canceled out and just left you with 3 pi. But you know what? We're just going to go with that. Midline, I'm going to go up to my max and my min, right? This is going to be using my amplitude up here. Even though we have a negative value, I'm still going to be going up and down the same distance. It's the way I draw the graph that includes the reflection, which means it's a reflection over the x-axis. So everything that was up top is now going to be at the bottom, and everything that's at the bottom is going to be up at the top. So essentially, we are going to flip that over and create a reflection. It's going to be upside down, basically. So whatever, when you went up, you're going to go down at this point. Since this is sine, we normally would just go up with sine. Now we're going to go down with sine. Okay, let's add all the elements. We're going to go with 4. We're going to add those values up top and down at the bottom. I'm going to go ahead and add all the values out here by using my increment. So let's look at my increment. In this example, 3 pi divided by 4, and that's it, right? I don't have to really do anything to that. So we're going to go ahead and I'm just going to add 3 pi. Actually, let me do that. We're going to add 3 pi over 4 plus 3 pi over 4 plus, so I'm adding 3 every time. So 3 plus 6, or plus 3 is 6, plus 3 is 9, plus 3 is 12. Now, I didn't really reduce those yet, but you see that I just added 3 to the top because we're adding 3 pi over 4. Since they already had a 4th as a denominator, since they're all the same, I just get that easily done that way. I wanted you to know also that when I start at 0, the very last number, because it's one full period, should match my actual period value, and this does, right? Notice how I drew this one. I started at the midline, I went down first, then I went back up. So really I'm drawing this in the opposite way I've normally drawn my sine function. Right? Every max becomes a min, every min becomes a max. That's really all you have to remember. Also, the midline, you notice here, all stay the same. We'll go in and reduce these. So 6 pi over 4 reduces to 3 halves, and then 12 over 4 reduces to just 3 pi. And that's how you would graph with a sine function with a negative coefficient and a fractional value for b. It's not a big deal, just get used to the fractions, okay? I hope this helped clear up a few things, and maybe you can kind of look at it and rewatch it if you need to. Try getting those things done on your paper and submitting them on the assignment.